Our next session is titled Improving Cybersecurity Through Cloud Adoption. We are pleased to have with us today Mark Ryland, Director of the Office of the CISO at Amazon Web Services. He will share insights on how moving to the cloud can help organizations strengthen their cybersecurity strategies and protect their data. Gracias.
Good afternoon, everyone. My name is Mark Ryland. I'm a director of the Office of the CISO at Amazon Web Services. Thank you very much for including us here at this event and also for indulging me speaking in English this afternoon. My Spanish is not up to the task, so again, appreciate your indulgence. I want to talk today briefly about improving cybersecurity through cloud adoption. I'm going to start with a story. It's a true story. It's a story about a system we developed we call MadPot. So what is MadPot? You've probably heard of honeypot systems. Honeypot systems are systems that appear to be vulnerable. Implementations expose themselves to attackers, observe the behavior of the attackers, and gain threat intelligence from what they observe. And these kinds of systems have been around in the industry for a long time. But we took this concept of MadPot, of a honeypot, and we made a cloud version of that, which means that we built a gigantic global sensor system running in dozens of regions around the globe. Each Amazon region, as you probably know, it's a metropolitan area with at least 3 availability zones. Each availability zone has at least 1 data center. And that's how we deploy our cloud infrastructure in these autonomous regions. And across dozens of regions, we've deployed tens of thousands of sensors observing all of the interactions that come from the internet. Within a region, hundreds and hundreds of servers are constantly listening on all the different ports and attracting traffic from bad actors. Once that traffic arrives, we allow these systems essentially to be attacked, and we act as though we're exploited. We take the malware drops, we participate in the C2 systems, and by that activity, without actually going and doing any harm, we're able to infiltrate the networks of the bad actors, both at the what are called layer 4 attacks, DDoS attacks, and so forth, and also layer 7, which is more and more the trend in the internet, is to use what are called open proxies or proxy-based attacks with layer 7 traffic. So MadPot appears to the bad actors of the world to be vulnerable systems and open proxies which are subject to exploitation. But actually, of course, they are a tremendous source of threat intelligence about what the bad actors are doing, where they're located, who they are, which we can then use to protect ourselves and to protect the larger internet. So on the back end of MadPot is another system we call Sonaris. This is the active defense system. So Sonaris takes all of the threat intelligence from MadPot, as well as many other data sources, and begins to actively block the bad activity. So at the edge of our network, we can stop all the traffic from the C2s, from the proxy drivers, so that our customers, even if their software or their systems have been compromised and have malware running inside them, they will not participate in all this bad activity. We can also detect scanning, so network scanning. Obviously, there's some valid uses for network scanning, but many bad actors also scan the internet looking for open ports and hosts that are available for compromise. And we block bad activity at the edge of our network using the Sonaris system. Using these technologies, we're able to process more than 98 billion signals using our MadPot service, infiltrate more than 60 million networks over the course of the last 12 months, mitigate 12 million DDoS attacks, We also issue takedown requests when we detect that the bad actors are using another provider. We inform those providers and give them lots of detailed information which allows them to make a decision to then take down that bad actor, so revoke their rights to use this outside systems. So, and we've also been able to block trillions of malicious scanning requests, S3 bucket scanning, which is a thing I'm sure you've heard of, people looking for open buckets. We mitigate that so that even if your bucket is open, which you should not have open buckets unless you have a very good reason to do that. But even if you make that mistake now, it's very unlikely that someone will find that because we don't allow these the scanning of our bucket namespace the way that historically was possible. So as a result of all this activity, our customers running inside our networks see about an 80% reduction in the total volume of malicious traffic that hits their endpoints. Now you might say, well, why not 100%? And the reason is because we have to be very careful and very cautious about what we block, because if we're not sure it's bad activity, we might be impacting someone's production system, right? There is a lot of weird stuff that goes on in the world and in customer systems, and so we have to have a very, very high confidence that activity is bad activity before we feel comfortable blocking it automatically. Now, another good thing we do is we run our MadPot sensors both behind our protections and outside our protections, and we can do very useful data science and analysis to compare the behavior, and that's how we come up with these statistics. We know with certainty that, for example, about only 0.002% of these mitigations were not malicious activity, because we can compare and contrast between our protected systems and our unprotected systems. And we're not just making our network safer, we're making the internet safer, because again, we issue takedown requests, we have a lot of cooperation from other vendors in the industry, other ISPs and hosting providers. They're grateful that when we tell them, hey, you have a customer who's doing bad things, and they become, over the last few years, more and more responsive. At first, people didn't really know what to do with this information, and now, much more routinely, we see these bad systems taken down, DNS names that were used by malicious actors are removed, and so the internet as a whole gets safer through this kind of activity. So why did I start with that story? I wanted to give you a very concrete example of my general thesis, which is how cloud adoption can improve cybersecurity. So now let's kind of zoom back and look at the broader questions around cybersecurity and why cloud adoption is considered more secure. And I'm going to use both the term cloud generally, but really I don't know other cloud providers as well as I do my own company, so I'll be talking specifically a lot about what AWS does. But you can generalize many or most of those things, I believe, to many other providers. So these are kind of general statements about how clouds operate. But again, many of the specifics have to do with my company, the one that I'm familiar with. So many people in the industry are recognizing that cloud adoption can really help cybersecurity. For example, in the United States of America's National Cybersecurity Strategy, a strategy document for the US government from a little over a year ago, they actually call this out. Cloud-based services enable better and more economical cybersecurity practices at scale. So they're encouraging cloud adoption, both for government and for business. And some of the reasons for this are the very professional, we make huge investments and billions of dollars in the hardware, the software, the data centers, the security experts, the networks that allow us to provide a very, very secure and firm foundation for our customers. Now they come onto that very secure platform and they use this API-driven infrastructure. So that means that every single thing you can do that a human can do, typing a command or clicking through a console, can also be done by software. So that allows for automation to then become the prevalent way that you interact with your IT systems. Instead of humans doing human activity, that's a good way to start, that's a good way to learn, but production systems should be driven by software. And by using software, we can avoid a lot of the problems we've had with cybersecurity of human mistakes or human neglect or negligence or too many things to do and I don't have enough time. What you do is you take your security experts, pair them with a software engineering capability, and write code to do the things that historically we had to do in a manual way. There's also the unification of identity and access management across the entire platform. All of the APIs are logged in a common way. I mentioned already things like MadPot, Sonaris, many automatic improvements. They're constantly trying to raise the bar on the security of the systems and all the systems running inside the cloud. Cloud providers like AWS can also make very deep investments in cutting-edge technology that doesn't make sense or is not really possible for individual companies, even large ones, or even governments. But it is possible when you're investing at the scale that we invest. And so we have very profound innovations, things like a key management service, KMS, our key management service, that is something that's never been done before. It's both a FIPS 140-3 validated hardware security key module, so it goes through a rigorous process to prove that it manages keys in a secure fashion. But also, it's a large-scale distributed system, actually made up of hundreds and sometimes thousands of these devices working together to provide millions of key operations, millions of encryption operations per second for customers that are working at cloud scale. With extremely high availability, failover, fault tolerance, and this is, again, it's never been done before. So you get really of both worlds. And another example of that is our investment in something we call the Nitro system, which is a total reinvention of how virtual machine technology works. I don't have time to go into that, but I encourage you to do a web search on the Nitro system and learn a lot more about how we've built a very unique and secure way to run virtual machines, protecting customers from each other, from protecting us from customers, and actually protecting customers from us. We make it so that your compute workloads are completely isolated, and even our most privileged administrators working for our company have no access to the data running inside your servers. And all this is done with a continual oversight of third-party audits, because again, we're a vendor, we make all these claims. You could say, well, you may not be telling the truth. I hate to say it, it's happened in the industry that vendors have not always told the truth. Recognizing that, we understand, so we work with companies that have no vested interest in our success or not, third-party auditors, working on various different compliance regimes on behalf of different parts of the industry, everything from the US government's FedRAMP program to the SOC reports, which are auditor-to-auditor reports, backed by, again, international accounting firms. And even something seems a little off to the side, like the Motion Picture Industry Association has a very rigorous cybersecurity framework. Think about it. Some of the most valuable digital property in the world is an unreleased blockbuster movie, and so they really care about the systems that host their content, and they have a rigorous cybersecurity standard, which was kind of to our surprise years ago when working with some of our customers like Netflix. We realized that they're serious about cybersecurity, even though you would think if it's Hollywood industry, like why would they care, but they care a lot. And so we have to operate under the very rigorous scrutiny of all these different auditors and compliance regimes, which really helps make the whole platform stronger. Now, you've all heard of this concept, I'm sure, if you know something about cloud, the idea of shared responsibility. This basically means that, look, there's a bunch of things that we take care of automatically, and your experts have a lot less to worry about, but you still have to deploy and operate in a reasonable way on the platform. The platforms are flexible. They have a lot of features. They have good defaults, but you can change the defaults, and so you have to exercise care when you use the platform and do so in a reasonable way. Again, the advantage is there's less to worry about, but you still have to be careful. But at the same time, we don't consider that a static line. We're constantly making changes, improvements to increase the ease of the use of the platform, to make it so it's harder to make mistakes, to make it so that there's less things you need to worry about. We're constantly making those changes and improvements based on customer feedback and the experiences of customers, and also moving from more, let's call low-level services, which have lots of features and flexibility, but maybe more than you need, to higher-level services where we take care of far more of the things that you're concerned about. So when you look at a slide like this, you can see that you can come onto the platform, often with sort of lift and shift, take your existing on-premises applications, move them to the cloud, and you'll typically fall into that left column where you have a lot of things are done for you, but you still have a lot of responsibility because you're using traditional on-premises technology, but you're using it on a cloud hosting platform. But as you're in your journey and as you migrate and as you grow and as you evolve, you're going to be shifting to the right. You're using more of the high-level cloud services. And in those services, we take care of more and more and more of the things that you used to have to worry about. Things like patching and various maintenance. So for example, to take the compute example, if you start with a virtual machine and you have to manage and control all the software, the Linux operating system, the Windows operating system, and so forth, we give you services to help you do that. We have patch managers and various tools to protect your systems, but still, you have to use those and manage those. But on the other extreme, when you move to our Lambda service, which is a service where you literally upload code snippets, and we execute those functions when certain events fire. And when you get to that point, the only thing you have to be concerned about is the code that I've written, my business logic, and I've uploaded. Is that secure or not? That's your only concern. We take care of every single thing else below that. The containers, operating systems, hardware, networks, everything below that is managed by the cloud provider. Now again, cloud adoption, you shouldn't think of that as in isolation. It's part of a much larger trend that we're all participating in terms of IT modernization. Modernization occurs in many forms, and it includes things like you've heard of secure DevOps. So we're moving security more and more into the engineering processes. For many years, for decades, we made the mistake of building applications as sort of a separate exercise, and then that whoever built the system would hand it over to a security team and an operations team and say, hey, good luck, I hope it works for you, but we think it's okay, now you go make it secure. And we all realize now that doesn't work, right? You can't bolt on security at the end. You can make some improvements, it's not completely fruitless, but it doesn't work very well. So more and more as an industry, whether you're in the cloud or on premises, all of us are modernizing these techniques and practices to inject security concerns, requirements, analysis, threat models into the software engineering process so that it's a continuous process of securing a system and not something that's attempted to be done at the end. So that's a very general trend in terms of modernization. Cloud is a major part of these things. Things like secure DevOps really were pioneered in the cloud because, again, everything is programmable. Every operation can be turned into a software operation, which allows you to then automate all these systems to take care of to make it to decrease all the manual operations as much as possible. So just writing code becomes the critical thing that humans are still doing. And of course, with AI, more and more machines are helping us write the code. So that's, of course, a very general trend. And the way people migrate to the cloud varies a lot depending on the size of the company or government agency. I want to talk a little bit today, I think important in this setting, about the small and medium-sized business, because that's a really important segment of our economy that often has not gotten much attention or love when it comes to these IT trends and cybersecurity. But the general pattern is companies, agencies tend to shift their kind of, I'll call them horizontal business applications, emails, document management, to a SaaS provider. That's already happening very broadly. Very few companies run on-premises email systems anymore, for example, or government agencies. Then they take their custom applications that they have written specifically for themselves, and they migrate those in this what's called lift and shift, which is change as little of the code as possible. It can be very, very little change, almost zero. Move that to a cloud platform, and then from there, modernize and make progress. New engineering projects are very much now starting in the cloud. Very few companies, even large, small, whatever size, are starting major new application development processes that are not cloud-based or cloud-centric. Especially now with the emergence of generative AI and the big impact that that's having, you're looking at, cloud as sort of the heart of that generational shift. Whether it's the small number of entities that develop the models, the very large number of companies and agencies and entities that will consume those models as a SaaS or a platform as a service. All this is also very much a part of cloud adoption and IT modernization. For a small and medium-sized business, you might say, well, what's the security benefit? Especially lift and shift. People often ask that question. If I'm just moving systems from on-prem to the cloud, why would that give me any security benefit? And the truth is, with very, very tiny changes, in fact, even just sort of the normal migration pattern, you get a lot of benefits actually from using on-premises application, moving it to the cloud. For example, right out of the bat, all the things I mentioned at the beginning, MadPot and Sonaris, so you're being protected from all kinds of internet-based security attacks that you would not be protected from if you're standing up your own endpoints on the internet. DDoS, I didn't focus on that, but we have to protect our own network, and we do it really, really well. And we have the massive capacity and the ability to shunt traffic and to grade traffic, so every single edge node in our system literally scores the packets as they come through on a probability of, is this a good packet, or is this a questionable, or is this possibly a problematic one? And as the loads increase, we start dropping the low quality packets. And pretty much certainly those are the attackers. So you're going to be protected automatically from a lot of these systems. But even in the core of your application, just for example, the database tier of a traditional 3-tier application, it's super easy and in the cloud and not very easy on premises to create a multi-AZ, highly available, automatic failover, automatic backup, snapshot, point-in-time restoration, all these features that are not that easy to do in a traditional IT infrastructure are really easy to do in cloud. So even before modernization, you'll get some benefits. And again, many new systems integrating with generative AI will also take this very cloud-centric approach. So these are some of the immediate benefits you get from using a software as a service, obviously professionally run systems on your behalf for your business applications. The use of MFA, which is more and more encouraged, and gradually we're now enforcing MFA for high assurance principles. We're rolling out a program to make it so that what are called root principles, the most powerful users in an AWS account, we're going to make you put MFA on those. Sorry, it's inconvenient. People, believe it or not, still resist that, but we're removing the option because it's just too important to make sure that customers do not get compromised in those very powerful principles. And over time, we'll push that further and further up the stack, if you will, towards principals who are not as privileged, but we should all be using MFA for all our humans interacting with these systems. So again, without much effort, you can make your on-premises software shifted to the cloud greatly improved. And another really important point about cloud migration, and customers taught me this, when I first started working for AWS some years ago, many years ago, I've been there 13 years, I had a little bit of an attitude of like, oh, don't bring your ugly old application to my shiny new cloud, you should modernize. The customers taught me that actually by bringing old systems to the cloud, it's much easier to update and modernize in the cloud than it would be to do it before coming to the cloud. Because, to just very simple example, I can literally make a copy of my application and run it 9 to 5 on Monday through Friday while my engineers work on it, shut it down on the weekend. That's something that you can't really do on premises. You'd have to acquire all that hardware for a short period of time. It would just be impractical. But in the cloud, you can actually do these parallel engineering projects very efficiently and very well. So in conclusion, as I mentioned, it's not magic. You still have to do careful work, but cloud can really help and provide a number of automatic benefits. Even lift and shift applications get some benefits. So again, you don't want to stop there, but it's still a good starting point and provides some good cybersecurity reasons to come to the cloud platform. And as I mentioned, modernization is easier in the cloud once you're there, the tools that are available, the new technologies, the ability to run things in parallel and only pay for what you're using and not have to buy extra copies of hardware, software licenses, et cetera. Again, that doesn't mean that you don't have to be careful. So shared responsibility remains an important concept, but we're also here to help. We have a big team of solutions architects that do nothing but help customers for free, essentially free technical consulting. We have all kinds of free online training. We have a big partner ecosystem who is there to help you as well. And if you have ideas for how we can be more helpful, especially in that small, medium-sized business case, we're working with INSEBID to to work in this space, because we know as a community there's more we need to do. And so we have some good ideas I think you'll see coming out in the coming months that will help broaden the impact of cybersecurity communities like this one and reach that smaller business with 10 or 20 or 100 employees who often really struggles dealing with cybersecurity issues. Thank you very much for your time. I appreciate it, and thanks for inviting me.